Hey, good morning, Algebra 2. I hope you are just raring for another great day of polynomials. I know I am. I mean, that's why I made this video early, before I even left. I just figured that was probably the most important thing I could do for you. Today, I want to talk about factoring polynomials. We're going to look at the factoring theorem and introduce a couple of additional remarkable identities. So, recall that if a number is divided by any of its factors, the remainder is 0. Likewise, if a polynomial is divided by any of its factors, the remainder is 0. And this is where that synthetic division that we looked at on Tuesday of last week really comes into play. Because according to the remainder theorem, if a polynomial is divisible by one of its factors, then the remainder is 0. And if my picture's in the way here, maybe I'll just try to sneak myself out of the way there. And what we're trying to say then is if you evaluate that polynomial for whatever a is, and you get 0 out of it, then that is a solution. What in the heck did Mr. Rising just say? Well, let's try it. So here's what I want you to do. Take a look at these problems, okay? And you're going to determine whether or not x plus 2 is a factor of this expression, or if 3x minus 6 is a factor of this expression. So here's what I want you to do. Let's have tables 1 and 3 do this problem, and tables 2 and 4 do this one. So, Mr. Fernandez, if you'd please just pause the video for a second, give the tables a chance to work, and then I'll jump right back in. Poof! Welcome back. We're back in. So, tables 1 and 3, you went ahead and looked at this problem, and of course you set it up. So you said, well, the form is x minus a, and in this case, if it looks like x plus 2, that means a has to be a negative 2. So then you set up your synthetic division, right? And you looked at this and you said, okay, so I've got factors of 4, negative 2, and 5, or not factors, but coefficients. And you know a is negative 2. So then you performed your synthetic division, or I should say substitution, and you realized, wait a minute, you ended up with a remainder of 25. So when you plug in a negative 2, you get a 25 out. 25 is not 0, so then therefore you would say, nope, negative 2 does not equal 0, so x plus 2 is not a factor of this polynomial. Now, tables 2 and 4, you were given a similar problem, but there was a little catch. See, the book doesn't tell you these little catches. They just say, you'll figure it out. You've done this before. Well, wait a minute. 3x minus 6 and this whole polynomial, they all have a 3 in common. So I'm sure the first thing you did was, let's just divide everything by 3, right? So you did that. And then you realize 3x minus 6 really just becomes x minus 2. And a is positive 2. And then that's what they're doing here. They're saying, oh my gosh, it's really just x minus 2, and then all of these 3's, or all these values, get divided by 2. If you didn't do it that way, you should still get the same answer. It's just, don't forget these steps to simplify things. So when you complete the synthetic substitution, indeed you find out that this problem, you get a remainder of 0, which means that if you plugged in a 2 into the problem, right, you would get a 0 out of the problem. Let me move my beautiful face over here out of the way. And lo and behold, 3x minus 6 is a factor of this problem. Okay, so here's the big deal. Factoring. The rules for factoring polynomials are the same for factoring quadratics. Step number 1, remove the greatest common factor. If you have a negative as a leading coefficient, you might want to divide everything by negative 1 right off the bat. 2, is it the product of two binomials? Is there anything that you just recognize right off the bat as, oh, wait a minute, I can do something about this? Don't forget the difference of squares. or as Emma likes to put it, the remarkable identities. It's great. So here they are. This is the review of difference of squares, or this is difference of squares. This is a plus b squared and a minus b squared, right? And then 3, grouping. And I wrote here grouping is math magic, because you will see problems that at first you're like, how in the world did they come up with this thing? But once you see the tricks, you'll start to do some pretty cool math magic tricks. All right, let's try a couple of problems. I'm going to go to the board here. I'll try to speak up so you can hear me loud and clear. The first one says, factor 4x squared plus 28x plus 24. Well, the first thing you would do is say, hey, well, wait a minute, Mr. Rising. I can take out a 4. So you actually go ahead and do that. Divide everything by 4. And 6, and then you say, oh, wait a minute, this is just 4. This is x plus 6 and x plus 1, right? No big deal. Now, what if I said, try this problem? Now, you look at this problem and you think, there's no greatest common factor. So, there is no greatest common factor. I've got I've got something to the 3rd power. So let me try to group. So hey, let's just go for it right now. So let's say x to the 3rd plus 2x squared. I'm just going to group that. And then I've got let me just do plus negative x minus 2. Now, really what I want to do on this side is take out that negative. So I'm going to rewrite it as minus x plus 2. And this one here, let's see, is there anything I can just, let me put a 1 there, just for a little kick. Really, because I'm taking out a negative 1. We don't typically write it as negative 1, but that's really what I'm doing. Now, over on this side, what does x to the 3rd and 2x squared have in common? Of course, they have an x squared. So that leaves me with x plus 2. Oh! Now, you can see, what can I factor out of both of these terms? Well, I can factor out an x plus 2. So I've got x plus 2 times x squared minus 1. And you're thinking, high-fiving each other, right? We're done, right? No, because someone, I just heard, I couldn't tell who it was. Was it Jalen? Jalen, was that you? It might have been Neil. It was quiet, but I heard it out of the corner of my ear from this side of the room. And somebody said, but Mr. Rising, isn't x squared minus 1, isn't that one of my remarkable identities? And you're right, it is. It's the difference of squares. Let me extend my page. So I've got x plus 2, and x squared minus 1 is really x plus 1, x minus 1. Now this is completely factored. And you can see that the next step when we really look at polynomials is, what are your solutions? Well, one solution is negative 2, one solution is negative 1, and one solution is positive 1. Isn't that cool? A little bit of math magic. So just as there are special rules for differences of squares, there are special rules for factoring the sum or difference of 2 cubes. I think it's really important that you get this in your notes. Mr. Fernandez, if you want to give them a minute, or not, if they're giving you a hard time, just say, nope, it's in your book, we're moving on. Okay, so let's practice a problem like this. It says factor this expression, 8 plus z to the 6th. You're thinking to yourself, how is that a cube? Well, just go back to your rules for a second. This is 1 cube plus another cube. So once you recognize that, actually this isn't so bad. You recognize it as 2 cubed and z squared cubed. All right, so rewrite the problem as a difference of cubes, and then use the rule to set it up. Basically, all you're doing is setting it up and substituting. And last but not least, simplify everything out, right? This makes it a really nice sort of straightforward procedure. You'll have some more practice problems on that, but refer to this if you need to. The last thing we need to talk about today, or maybe, well, yeah, it's really the last thing we need to talk about today, is word problems, right? They always give you a word problem because it's really important that you recognize what to do here. So, Connor, would you read the problem, please? Very good. Thank you, Connor. I appreciate that. So now, if you look at the graph, you'll notice the line, the polynomial, crosses the x-axis at 3 points, where x is 1, where x is 3, and where x is 4. So these are considered the solutions of that. So once you know that, really, I know that these are factors. So like x minus 1 is a factor, x minus 3 is a factor, and x minus 4 are factors, right? So it says identify values of x and then graph, and then use the graph to help you factor it. Now the book goes into this example of synthetic substitution really just as a way to check. So if you said, hey, well, x minus 1 is a factor, you can set up your synthetic substitution and you can check that. But this is a really helpful way to factor a polynomial that you just can't look at. Because if you recognize, wait a minute, it's got a 0 at x is equal to 1, then you know x minus 1 is a factor. And if you complete the synthetic division, right, this is the x squared, this is minus 7x, and this is 12. You know what the remaining polynomial is because you can multiply x minus 1 times this expression and you'll get your original equation. That often helps you get to the next step because then you say, oh, well, now I can factor that. That's just a trinomial, quadratic trinomial, and it's the product of two binomials. Okay, so here's what I want you to do. Mr. Fernandez has a worksheet 3.4. Please help each other. I'd like you to complete it during class. Again, the idea of giving you a lot of homework is not the intent. You have enough going on in your lives as long as you're working hard here. And then when you're finished, work on your Khan Academy. Again, 40% by the end of the semester. Thank you for another great class. Send me an email if you have any questions, and I look forward to seeing you in school on Wednesday or Thursday.